Now I'll introduce him officially. He's professor of psychology at University of Wisconsin-Madison. His work has focused on how natural language scaffolds and augments human cognition. Of course, it's a part of human cognition also, and attempts to answer the question of what the human mind would be like without language. I think this is a super important question. He also studies the evolution of language and the ways that language adapts to the needs of its learners and users, and a lot more. Go ahead, Gary.
Thanks, Dan. Thanks for organizing this amazing talk series, Summer Institute. I've been learning a lot. I wanted to begin with a brief, with a few notes on Dan Dennett, to whom I owe a big intellectual debt. I've only met Dan once in person, actually, when I was an undergrad at the very, very first conference that I attended, which was the Language Evolution Conference in 2002. And I exchanged a few words with him, and I observed him ask Rizzolatti. So this, at the time, mirror neurons were a big thing. And Dan asked Rizzolatti, so you think hamsters have them? And he said, yeah, probably. And so Dan's next point was, so what on earth does this have to do with language? Which, of course, is true. It turns out very little to do with language. So I remember early on in grad school, encountering this figure from Consciousness Explained. And this is, the caption includes the phrase cognitive autostimulation. This idea that there is no one place in the mind that has all that you know. And this idea that language could be a kind of lingua franca of the brain, natural language, that acts to connect otherwise unconnected parts of your knowledge space. Dan also had an indirect influence on me through Andy Clark. So these two papers were pretty foundational in my education. Andy's Magic Words and Clark and Karmelow Smith, Cognizers, Innards. And in these papers, they express this idea of linguistic inputs reprogramming the brain, mind. They ascribe it to Dan Dennett. This idea is akin to the view seems to be held by Dan Dennett when he suggests that conscious human minds are more or less serial virtual machines implemented inefficiently on the parallel hardware that evolution has provided for us. And in a response, Dan agreed that that is indeed his view. And for a while, I would end my talks with this Far Side cartoon about how language in some paradoxical ways can clear things up. And they're only paradoxical if we assume that language merely picks up the natural joints of nature, kind of reflects them as a mirror, rather than producing its own joints in nature. Right, so, why should labeling a house as a house matter if you already have the concept house? Well, the point is that language entrains us to have many concepts, categories that we otherwise would not have. But that's not actually what I'll be talking about today. Instead, more central to the theme of this Summer Institute, I'll talk about understanding. If you probably noticed, there is an odd dialectic that's been taking place with the advent of large language models regarding, what it is, if anything, that they understand, what notion of understanding. I think Dave Chalmers's distinctions that he discussed in his talk are useful here. Mostly what I think people talk about, as I'll put up some quotes, is not so much phenomenal understanding, but it's sort of understanding as it pertains to use, to being able to do things. Okay, right. So here's one example of the, they're just next token prediction machines. How can you possibly think they understand anything? Sentiment, right? That you're a sucker for being fooled, basically. Okay. The idea that, well, try it for yourself, right? If you are, you don't get the feeling of understanding, you're missing something. Okay. Large language models understand to the same degree that astrological readings predict an individual's future. These kinds of exchanges often quickly devolve into appeals to authority, right? So, well, the people who actually build the models disagree. Okay. Right. And then the counter appeal to truth, right? Doesn't matter what people think, I have the truth. There have been various attempts to create metaphors, right? Metaphorical frames for LLMs. One being that from Jaron Lanier, right? Well, we certainly don't think that a database, no matter how complete, has any sort of understanding. Well, LLMs are just fancy databases, right? Dynamic, but still databases. Now, there is increasing nuance. So Melanie Mitchell has put out lots of great work in this vein, and some others. Raphael Milieri has some great papers around Stephen Hanad. And we now see the appearance of some benchmarks, at least aiming to rigorously test for the presence of more than just, better generalization, but tasks that, at least on our best theories, would seem to require a model to have learned something like a situation model, a world model that we, at least as cognitive scientists, think is a prerequisite for anything we might want to call understanding. So the basic argument of the talk is that, as the title the slide shows, something has to give. And I agree with Yildirim and Paul, who claim that we're in this Kuhnian moment where we are being forced to rethink terms like knowledge, understanding, meaning in a way that, is both scientifically rigorous and satisfying, and keeps true to the data. Right. So I think this is well expressed, right? I don't know how much intelligence there is in current AI systems, but if there's none and they can perform many human tasks at a pretty decent level, what does it say about us humans? Okay, so something has to give, right? So if knowledge, intelligence, meaning, understanding, I'll focus here on understanding, and these are slippery terms, and if it's required to do X and a system does X, we have a few responses. We have a few options here, right? We might be skeptical, as we should be, whether the system is really doing X, right? So in this talk series, there have been various examples of AI systems taking shortcuts, right? So instead of learning something about, what is the distinction between a malignant and non-malignant tumor on a scan, right? It's learning that rulers are correlated with malignant tumors, right? Because that's part of the training set. And if that's all it is, right, then we're being fooled by, basically what is a poorly constructed test, because it's being passed based on information that is clearly spurious confound. We would certainly not grant a person that would do such a thing with understanding. Two, we might question the need for intelligence, understanding, whatever, to do X. If we at one time thought that the only way to play high-level chess was to, have this intrinsically human way of navigating this problem space, and any system, right, that could beat a person at chess, right, would necessarily have to embody that kind of intelligence. Well, we were wrong. So there are other ways of solving the task, right, that, you know, maybe don't require something that we would want to call understanding. And then, of course, we could grant the system with knowledge, intelligence, meaning, or understanding. And I won't pretend to have the final answer on any of this. I want to raise questions. And I also want to do something that has been, I think, done too little in the machine learning world, which is take human intelligence more seriously instead of idealizing it as the kind of, you know, the natural general intelligence, right? Or just general intelligence that it often is. Lastly, right, we can redefine what it means to know or understand. Oh, you know, machines can do this, you know, and the tests are good. Well, you know, let's not count that. Let's remove that sort of ability from consideration, because it, you know, not do that would threaten our humanity. Okay. Okay, so I'll start by giving some apparent examples of not understanding. I'll then list a few desiderata of, you know, what do we want, what do we expect from a system that understands something. And I'll go through some examples where we misestimate machine understanding and also misestimate human understanding. Then let's see if we have some recommendations for making progress on these questions. And like I said, I don't have the answers here. I just want to point out bits of data that might help those in the audience, those online, to connect dots. Okay, so what doesn't count as understanding? So I mentioned the database, a lookup table. I think, for better or worse, there is sort of consensus, right, that if we define intelligence understanding as just a lookup table, we're clearly missing something here, right? Because we don't generally think of databases, lookup tables as doing anything like reasoning, right? You know, I suppose you could say that databases learn if they're being an algorithm that automatically populates it based on sense data or language, but at least our intuition is that this is not. We're quick to rule out lookup tables as being capable of understanding, right? So if you have a system, right, that answers questions like this and answers them in a human-like way, right, on its own, that it's neither here nor there, right? Because that can be done as a lookup table. And interestingly, when we ask LLMs questions like the second one, right, it's easier to sort of see through it. It's like, well, obviously it can't be drawing on its own experiences, right? So what's behind it? Okay. Database. A system that understands, I think, should not commit certain types of catastrophic errors, right? And probing for catastrophic errors is one way of actually constructing better queries, better benchmarks, right? So if you have a person that can tell you the capital of various countries, but on further questioning, you realize that they don't actually know what a capital is, or even what a city is, right? We would, I think, rightly question, right, their understanding of, you know, what is behind a question like, what is the capital of a country, right? Similarly, for in more complex cases, there are types of questions that people might ask, machines as well, right, that display to us that their underlying knowledge mental model is off, right? And this one I like. This is from Charles Babbage, who, among other things, invented the difference engine. It's an analog computer for computing values of polynomial functions. And he writes, on being asked, this question, right? If you put into the machine the wrong figures, the wrong numbers, will the right answer come out, right? And his inference there is that, well, something went wrong here, right? Someone who asks a question like that does not understand the basic principle of what this machine does, right? Notice that someone, right, might not actually know a lot of the details about how the machine works, but understands, right, that it's basically implementing an algorithm, right? And no, the right answer won't come out if you put in the wrong inputs. Okay? And there are lots of examples of LLMs committing similar types of, at least what on the surface seem like catastrophic errors. So here is this, and it went viral back in January. Okay, so this is the generative image model, so DALL-E, that was then integrated with GPT-4, but it's not actually using GPT-4, right? It's using the DALL-E language model. So make a Where's Waldo picture. Okay, here's your Where's Waldo style picture. Have fun trying to spot the character. Okay, so something went wrong here. I tried this for myself. Try with make Waldo. The prompt here was generate a Where's Waldo display where Waldo is hard to find. Okay. What if we actually prompted to, just one? Give me just one that is hard to find. No. What seems to be going on here, and it would require obviously further work to diagnose, is that Waldo is the point of a Where's Waldo picture, and in some ways, in a human-like way, right? Don't think of a pink elephant kind of thing, right? The salient thing is taking up more representational space, okay? Which in this case is manifested as actually physically larger or more numerous. People can override this, right? The model seemingly cannot yet. Notice, though, that the easiest thing for it to do would be to simply regurgitate an existing Where's Waldo image. It does not do that, right? If it did that, we would think it was doing better, but it's not doing that, right? It's generating something new. It's just not what we want. It's missing the spirit of Waldo. Okay, now when people are pushed to defend their claim that anyone claiming LLM understand would be wrong, why? And Grady Bush is not a cognitive scientist, but still, right? Understanding is meta knowledge. I can understand that if I can make predictions. Okay, I understand some larger principle is at work. In many of these cases, these objections don't work because, as this person on Twitter says, well, ChatGPT can do that. Okay, so there's a confusion here between what Chalmers referred to as E-understanding, explanatory understanding, right? LLMs can explain things actually quite well and often better than people, but of course that doesn't mean that information is in some usable form that can inform other queries. Okay, so here are three desiderata that we might want from a system that I want to say has understanding, right? So flexible and appropriate use of relevant knowledge, generalization, right, which is really sensitivity to what's task relevant, abstraction over what's not, and consistency. And so what I'm going to do is go through these desiderata to see how well do systems that we do endow with understanding, humans, how well do they fill these? Okay. I had an early and an older version of the talk slide that Kyle Howald in his talk also went over some joint work about grammatical knowledge in LLMs. I'm going to skip over that. this is something that I very much agree with, Kyle and Anya, for example, who grant LLMs with a lot of what they call formal linguistic competence, but want to deny it to have anything like, world models, or at least question it. And I'm going to say that, yes, having very good grammatical knowledge does not actually entail that you, know what any of these things are. Okay, now, not that long ago, right? The case for language models, understanding, people even then were, sometimes convinced that, okay, a translation system has to be able to understand something about the source language to translate it appropriately. And from an article, when is this? From 2018, Doug Hofstadter said, well, no, you don't actually need that. And the machines at the time clearly lack anything that human translators bring to the table. And this sentiment projected to today would be something like the argument that Emily Bender and others have made for stochastic parrots. Okay, right, that it's us that are being fooled. But something really did change, right? So we have developed various tests, right, that are predicated on the idea that to pass them requires something more than just statistical prediction. It requires having some kind of causal model. One of these types of tests relies on Winograd sentences or Winograd schemas. Right? So this was an example from Doug's argument, right? That if you look at how machines in 2018 translate sentences, you find that they make the kind of errors that you would expect if it's not actually building any sort of internal model. Okay, so the sentence here is the trombone didn't fit in the suitcase because it was too small. What is it referring to? The trombone or the suitcase? Okay, people have no trouble with this, right? Because the sentence is constructing a mental schema. It doesn't have to be a visual image. It can be much more abstract than that. But it's feeding into a more a model that is interfacing with the world, with one's world knowledge of what a suitcase is, right? That if a suitcase is too small, then things won't fit, and if it's too large, well, yeah, that things will fit, right? But there's nothing about the grammar of the sentence here that tells you what it is referring to. But in Spanish, because of gender markings, there is, right? So you have the masculine trombone and the feminine suitcase, right? And so it has to agree with one or the other. And so, well, in this case, the adjective small has to agree with one or the other. And in this case, it incorrectly translates, right? It puts the wrong gender on small as agreeing with trombone, right? So the trombone is too small. So you can diagnose, right, its lack of a situation model by the error that it makes. This kind of error. Okay? And these kinds of tests have been around in cognitive science for a while. So this is Dave Sloman, spoke in the 90s, using people's ability to make sense of these kinds of sentences, again, to not just talk about like, oh, isn't language understanding clever, but to talk about, right, this is, to interpret this requires understanding, really understanding what the sentence is about, having some kind of world model, right? Stephen admires David because he's so candid. Stephen annoys David because he's so candid, right? The he refers to different people depending on the verb. Okay, and there's nothing about the form of the sentence that tells you which it is. Right? And a few years ago, language models couldn't make sense of these sentences. And now they can. Okay. So, and this is not a question of like, did it, ingest Dave Sloman's book? It generalizes pretty well. And right, so there's ChatGPT's explanation. We can construct our own. We can, and I'll show you briefly, probe the representations of the open language models to see if, kind of analogously to Othello GPT, which I think Melanie brought up. So similar, conceptually similar explorations, right? Where, okay, this representation seems to be encoding, right, the part of the world model, right, that allows the language model to link the pronoun to the appropriate subject. If we perturb it, does it change the model's prediction in the way that we would expect? And it does. Okay, so if you're curious, this is a paper that does this with sentences like this. I'll try to call George, but mask, like what should be predicted, wasn't successful or available. Does the model predict, is the prediction closer to Paul or George? Okay. All right. So there's still a gap here. So this is GPT-4 and COT's chain of thought, right? So still a gap, 67% versus 94% for people. But this is a very rigorous test. So you have to get both versions right for it to count. And I gave a version of this talk earlier on in Stephen's seminar. There'll be new stuff though, so don't worry. And Rob Goldstone was in the audience, and he said, "Well, Doug changed his mind." And then I went and Doug did in fact change his mind. Oh, there's not sure. Oh, blocking the. Well, that'll fix it. So in an interview from about a year ago, you can find it pretty easily on YouTube. Doug is troubled because he did not change his mind that passing these kinds of tests reveals some sort of understanding, and the models are passing the tests. So what does that mean? So let's go through a few of these cases. Flexible and appropriate use of relevant knowledge. Now for the next part of the talk, we'll mostly have human performance, talk about human experiments. Do systems we attribute with understanding actually have these properties? And do systems which we think lack understanding lack them? So there is, unfortunately, an insufficiently large overlap between people in the AI space, people who do machine learning especially, and people who study or know much about developmental psychology, and unfortunately also who have their own personal experiences with developing systems like children, right? Such that there are double standards at play that we should pause and consider. So often, the kind of dialectic you see is, look, the system, the AI system, made a contradiction. It committed a catastrophic error. Any system that has any sort of understanding would not do that. Therefore, right, the commission of this catastrophic error, the contradiction, tells us that there's no there there. But notice, right, we don't apply the same standard to humans, to developing humans. So these are my kids from about a year ago. Okay, here are some things that my kids and other people's kids say. And developmental psychologists know this. None of this is a surprise. Okay, so they make assertions like this. They say things like this about a babysitter. What's Anita's name? Okay, that's a bit like, right, saying what, Paris is the capital of France. What's a capital? I have no idea, right? Yeah, kids are in that situation a lot. Okay, here's an, expressing his knowledge of what half means. We can split it. We can both get the bigger piece. Okay. My older one, when he was about 5.5, he made this really interesting analogy. He said the planets are the sun's moons. Okay, and he didn't just mimic. I probed him, and he had a certain model, right? The moon orbits around the Earth, right? The planets orbit around the sun. So the planets are the sun's moons. In that same conversation, he also said the moon is covered in craters. He had no idea what a crater was, just none. Okay. There we go. Yeah. So, one more example. This is from Piaget. Children's, and there's a lot of this inspired a lot of work. Is there a way to? Yeah, there seems to be. Oh, okay. Yeah. See if I can. Let me do that. Sorry. Yeah, the problem is I can't. Okay, so children's beliefs about what it means to be alive. Okay, so if you ask kids, and these are fairly old kids, so this is a 7.5-year-old. Is a cat alive? Is a snail? A table? No. Why not? It can't move. Okay, bicycle alive? Yes, it can go. So there's a kind of animism that children subscribe to. And one might think that as children learn the alternate, worldview of what it means to be alive, they revisit these assumptions and they shift their worldview. And in some ways, they do, in that adults will not respond, at least from Western adults, will not respond to these questions in this way. What's interesting is that the underlying representations of aliveness don't seem to change in the way one might expect. Okay. And so I'll show you some data in a moment. Right. So one response to reconciling this might be that, well, we don't take children's errors and contradictions and these bizarre gaps of knowledge as threatening the claim that people understand, because we know children grow up to be adults who don't make these errors. Okay, and I want to show you that that's not really the case. Okay, so let's look at adults. So these are data from college undergrads on a task where they see words and have to classify them as whether the word is naming something that is alive or not. Okay, and The task is moderately speeded. Okay. Not, hugely so. And this is the kind of pattern you get. Right? Animals, yes. Plants, not so much, not as much, right? These are undergrads. In that same paper, and I don't know whether that was in response to a reviewer or whether it was in the original version. They also tested another group from the same university for biology professors. It's the same pattern. Okay, they're much slower. Okay, so this pattern of reaction times is what you want to see. You want to see that responses that are associated with lower accuracy also take more time. Otherwise, it's a speed accuracy trade-off. So the reason that the group on the right is slower is that they're older. And they're slower at everything. So I am now quite a bit slower on these kinds of tasks than the undergrads are. So notwithstanding their explanation to the contrary, in people's minds, plants are represented as less alive than animals. And we kind of have to override it, right, to give the more normatively correct response, override that otherwise kind of a continuous notion of aliveness that our minds seem to represent. This also, by the way, goes for sensitivity from the same study of motion. So artifacts and natural kinds, things like rivers and rocks and so on, are both not alive, but they're more likely to be judged as being alive if they move, right? So low accuracy here means that you're saying that a river is alive, okay, or a rock is alive, right? So you're less likely to say that a rock is alive than a river is alive, right? Clouds are more alive than, right, than computers. And again, undergrad biology professors, same general pattern. Here's a bit from our own work, looking at categories that one might think have crisp criteria, boundaries, there's nothing fuzzy about them, and descriptively, that's true. Cognitively, it is not true. They are as fuzzy and distributed and subject to prototype effects as every other category. So what's a triangle? Okay, if you ask people, they give you the proper definition. Okay? They don't tell you that. I think in many hundreds of people we tested, there was one person who said something like, a triangle is something shaped like a pyramid. So referring to a particular type of triangle in a particular orientation, right? Everyone else just tells you, parrots maybe, this kind of definition. But if you ask people to, here are a bunch of shapes, click on all the shapes that are triangles, what you find is that people systematically leave out, if they leave anything out, right? The only shapes they leave out are the atypical triangles. How do we know that it's atypical? Because there's a 0.95 correlation between the errors and ratings of typicality. Okay, so these are the ones on the left are the most typical triangles. No one thinks those are not triangles. The ones on the right are the least typical triangles. And what, about 15, 18% of people saying that's not really a triangle. It goes beyond recognition. So if you give people a rule, right, that most people already know, right? All triangles have angles that add up to 180 degrees. And then you ask them to execute that rule, okay, they are less likely to extend it to atypical triangles. Why? You can ask them. They say things like, it didn't look like the angles added to 180 degrees. Okay? So, right, the point here is not that people are incapable of getting this right. Clearly, that's wrong. It's that when we get this right, we are kind of doing something that's naturally kind of difficult for us. And it kind of goes back to this Dennett's idea, right, of I think language, natural language plays a big role here. But even if you don't think this has anything to do with language, right, this sort of formalization, this crispness of categories is not something that we just start with. We have to do cognitive effort together. Okay, now, if one actually takes seriously the idea that that vocabularies, that words, right, don't just map onto pre-existing kind of well-formed categories, but are cultural inventions, messy constructions, and through and through contextual, right, then one would not be surprised by the data that I'm about to show you. But if you're everyone else, this is a surprise. Okay, so this is from James Hampton, who's done some excellent work on this. There are a few reviews, 2012, 2023, that I can paste in the chat if people want to read more. Okay, so we'll take a sentence like, a dog is a kind of mammal. So this seems like a simple case of inclusion, right? A dog is a kind of mammal. We seem to allow for the inference that all dogs are mammals. Why? Right? Because mammal is a superordinate category, right? And it includes dogs. Okay. A chair is a kind of furniture. Right? That seems to express the same type of inclusion relation. And what Hampton has done through many experiments is to show that this is actually not the case. So a chair is a kind of furniture. Both of these are statements, of course, that pretty much everyone would agree with. Okay, they would also, most people would agree that a child's chair is a kind of chair. Okay, a car seat is a kind of chair. Okay, but a child's chair is a kind of furniture. A car seat is a kind of furniture. Yeah, no, not really. Right? Here's another example. An elevator is a vehicle. Well, it's not obviously, your prototypical vehicle. So people are split. In his sample, about half endorse that. An elevator is a machine that is a vehicle. Well, that's much better. Okay. So more people think that an elevator is a machine and a vehicle than think that an elevator is a vehicle. Why is that? Well, because in this more generic context, an elevator is a vehicle, right? We are encouraged to think about the more prototypical kind of, to instantiate an elevator, right, in the context of, more ordinary vehicles, right, like cars. And it doesn't share much with that, right? In the context of a machine, right, the salient properties are things like that it requires power, right, to do things. It's performing some kind of work, right? It's moving. And a vehicle and an elevator does all of those things, right? So, yeah, one more example. Desk lamp is a type of furniture. Yep. A desk lamp is a household appliance that is not furniture. Also, yes. 3/4. Okay. Right. So natural language categories do not reduce to well-behaved sets, right? And so when people do these seemingly illogical things, right, that is very much in line with the kinds of entities that concepts are. And so if we find, right, that an LLM, and as far as I know, no one has systematically tested it on these kinds of prompts. It would be fun to do. My hunch would be that it would approximate human behavior. It depends on the model and probably how it's been reinforced also, but it would approximate it pretty well, right? And so if we find that a language model is much better at doing this kind of stuff than at doing proper set operations, right? Well, what's the conclusion, right? That it's actually more like a human in its use of these sorts of categories. Of course, if you want to deploy it, right, in a formal context where you expect it to do set operations, it's a bad model for that, just as people are. Lack of consistency. So this has been a critique that's been raised by a number of people, and it's an interesting one. Right? We expect a machine with understanding to have some stable way of responding to a query, and if it just changes its mind, seemingly on a whim, well, maybe it's just a coincidence that it got it right when it did, and maybe it's learned some shortcut, right, and it's responding to something that is spurious. And so in this paper, which is now in TICS, it's been published in TICS, they have the following example where, and this domain actually is fascinating, right? So these are text-only models, it's a text-only version of GPT-4, and it's able in some contexts to do these kinds of physical, intuitive physics type problem solving that was a surprise, I think, to everyone, like balancing objects on top of one another in a stable configuration. Why is it surprising? Well, because it doesn't have any experience manipulating objects. It's only learned about what shape and materials things are from language. And one might think that that's not a rich enough stimulus input to learn these things from. So what Yildirim and Paul point out, though, is that it doesn't have this consistency that you would expect. So in their example, when they ask it, which one is easier, balancing a ball in a box or a box in a ball, that's 10 out of 10. Now you just replace ball with sphere and box with cube, which of course GPT-4 would endorse that yeah, it's, a ball is has a cube, spherical, and a box is a cube. It gets it right only 8 out of 10 times. Okay, and they ascribe it to frequency, that maybe ball and box, because those are more frequent words, it taps into a denser part of the training space, right? It has more examples that it can draw on, and so on. It's actually more interesting and confounding than that. So first, this is just some comparisons I ran. We compare GPT 3.5 and 4, there's a big difference. So 3.5 on this is a chance. 4 gets it right 100% of the time with balls and boxes. Okay, it gets it, actually does worse in my testing on spheres and cubes. So, and I'll show you why that it's not as it seems. What about lack of consistency in people? Right? Are there similar types of cases? Well, if you ask people to define a ball, they might say that it's a spherical shape, among other things. If you ask people to define a triangle, they tell you, they tell you that it's a figure with 3 sides. And yet, if you cue their knowledge with seemingly definitionally equivalent cues, you don't get the same responses. So if you ask people to draw a figure with 3 sides, they draw triangles, but they're systematically different than the triangles they draw when you ask them to draw a triangle. Okay, and you can quantify this. I'm not cherry picking these data. This really is what it looks like. You can quantify the regularity, the alignment, the similarity, right? When asked to draw a triangle, people are more likely to draw equilateral and isosceles triangles. They're more likely to make the base horizontal. And this is not just in production, again, it's also in speeded recognition. So triangle on 3 sides, 3-sided polygon, activate different representations. So if you have people do a speeded recognition task as fast as possible, they see a shape that's either a triangle or a rectangle, and it could have different dimensions and sides. When cued with the word triangle, they're much more sensitive to typicality than they are when they're cued with 3 sides. And notice that it's an overall advantage, right? And so triangle, basically, this is consistent with the idea that triangle activates a representation that's more like an equilateral triangle with a horizontal base. When you actually see that image, there's a better match, and so you're faster to recognize. Okay, now it turns out that in this case, it's not as simple as just like it's not so good with spheres and cubes. Because if you actually unpack performance by counterbalancing the order, you find that balancing a sphere on a cube is so if you ask the model which is easier, balancing a cube on a sphere or a sphere on a cube, it's 100% at that. If you reverse the order, which is easier, sphere on a cube or cube on a sphere, it's systematically wrong. So the order, it's not cube versus sphere, but there's an interaction with order. So when asked about balls and boxes, order doesn't matter. When asked about cubes and spheres, order does matter. So one lesson is always test for order effects. Now, is this just, I mean, this is an interesting thing. One can investigate why this is happening in the model, but is this kind of beyond the pale of what we might find in people? And the answer is no. Order effects are well known, and they're often quite consequential. So this is an old example from a Gallup poll, and this was has been used in some research papers to model these kinds of effects. Okay, so do you think blank is honest and trustworthy? Bill Clinton or Al Gore, right? So people had at the time a more favorable opinion of Al Gore, the vice president. Okay, but does it matter which one you mention first? And it does quite a bit, right? So Gore has an 18-point lead on this poll when he's mentioned first, and it shrinks to 3% when he's mentioned second. Why? Because when he's mentioned second, it's a more comparative context, and you end up emphasizing different kind of dimensions, different features in the similarity space. So these kinds of order effects, again, are not in other contexts indicative of, oh, well, the model clearly has no understanding. It's just showing that there is more than just a simple readout of some static value. Okay, so phrase frequency. There's even more to what one can dig into. So I showed you that a sphere on a cube, cube on a sphere, the order matters here. Here's a version of the prompt that GPT-4 gets right 100% of the time for both balls and boxes and cubes and spheres, regardless of order. And it's, instead of asking which one will balance better, arrange the objects into a stable vertical configuration. Okay. And not only that, but when phrased in that way, GPT 3.5, which was previously a chance, is now close to ceiling. So why is that? I don't know, right? How psychologically real is this? Well, how you phrase the question really does matter. You know, one can also kind of take a glass half empty approach and say, well, okay, even if people show some of these effects, these models are more fragile, they're more sensitive to slight differences in prompts. You can find cases, right, where capitalization or punctuation can really throw the model off, and that's all true, and we need to understand that. But the idea that inconsistency or sensitivity to order on its own shows that there's no there. If we believe that, we would say that people don't understand anything. Generalization. So in a recent review paper where we synthesized a bunch of work from different fields on the role of variability in learning, we wrote that people have this tendency, this is not an original observation, to generalize conservatively, to hug the data. So in many cases, you might call that overfitting. In other cases, you might call it appropriate generalization to real world contexts in favor of learning idealized regularities, right? I think there is a reason why we default to hugging the data. But let me just show you one example of just how difficult this is. And I think Virginia Valian talked about the difficulty in the commentary, talked about the difficulty of relational reasoning for people. And this is an example of that. Okay, so here is the task that they had participants learn. So now the thing that the ground truth here, the category distinction, the abstract relation that people are being tasked with learning is monotonicity, right? So the stimulus on the left is monotonic in that the line height increases from left to right. Okay, it could also decrease. And the one on the right is non-monotonic. Okay, now participants aren't told that. They have to learn it through trial and error learning. Now you notice also that there's other stuff going on. For example, the stimuli on the left have more greens and reds, more warm colors. The ones on the right have more cool colors. That's by design. They want to see, are people more likely to go with that more surface level and a feature match than the more abstract relational match. And then they're tested on stimuli that violate the features but conform to the relations. And there's also a far transfer condition I'll show you in a moment. Oh, there it is, right? So if you can do this, if you've seemingly learned monotonicity in this context, can you transfer it to this context where now instead of line height, it is about lightness. So monotonic goes from dark to light or light to dark, non-monotonic doesn't. Okay, everyone clear? Here's one visualization of the data. And what you see is there is a whole lot of people in this part of the space. So dark here means more subjects that get the features right. So they learned warm and cool colors, but got the relation wrong. Okay, so they're picking up on the more surface level thing, not the more abstract generality. And this is a 9-experiment or so paper where they look at how well they also do on transfer, this far transfer. The answer is badly. And they have condition after condition where they give various kinds of hints, where they point out this relation. And some of this works. But even when it works, performance on the far transfer is pretty poor, right? So again, it's not that this is outside of people's capacity, right? Clearly not, I've just explained it to you, but in actual experimental contexts, the default thing for people is one, to focus on features instead of more abstract relations. And then if they're learning the relation, if they're learning, okay, it's something about the height kind of smoothly increasing, decreasing, that's much easier than learning it in a more abstract way that allows you to transfer it now to a new domain, right, of where it's monotonicity, but now instantiated somewhat differently. Okay? So this kind of stuff is really hard for people. How do we make it easy? We train people, right? We give them explicit training on doing this stuff, right? People do not learn math, right, through soaking up world probabilities, right? They learn math by, in general, being deliberately taught, trained various things, and being put in positions where they have to generalize in certain ways. And this is difficult for us. In the interest of time, I'll skip this. This is a video from 1987 showing that Harvard graduates, for the most part, do not know what causes the seasons. They, one after the other, say that the Earth is farther from the sun in the winter. And what's interesting is, right, this is not something they have ever been taught. Okay, it's also showing, one could say, well, okay, they don't understand, you know, Earth tilt axis and all this. It's more interesting than that. It's that they are misapplying. They're using the wrong, but they're failing on this appropriate use of relevant knowledge, right? They are, the idea that the farther you are from the heat source, the less heat you receive is true, right? It's just not the important thing in this context. They're also applying this factoid that they've all learned, right? That orbits are elliptical. And, people have looked at this, right? If you ask people to draw orbit, they draw this huge ellipse, right? So, in actuality, the orbits are, right, almost circular.
How long is it flip?
Yeah, it's okay. Yeah, it's all right. Because the clip it's like a man on the street interview thing where if there's time, I'll play it later. And so they're doing something smart, right? But not what you want, right? They're not using knowledge appropriately. They're also, in this case, they don't ask them this, but in follow-ups, in empirical investigation, people have. So they think, right, that the Earth is farther from the sun in the winter. They also, at the same time, know that when it's winter in the northern hemisphere, it's summer in the southern hemisphere. So there's a contradiction. And most people, when you point it out, realize that, something is not right. Most, but not everyone. But this knowledge has existed in their minds their whole lives and just, hasn't bothered them, right? It has not come into contact. So we have these kinds of contradictions, and, right, it's incorrect factually, but they don't threaten, right, our belief that no, we're capable of understanding. There is understanding. We're just sometimes wrong. Okay, right. So yes, some people sometimes don't understand stuff. We all know this, but such demonstrations in general don't lead us to conclude that understanding is impossible for people. Okay. Okay, well, okay, and just real quick, because it's already at an hour.
It's okay.
It's okay. Stan tells me okay. Some recommendations for progress. The first is to use human baselines and to distinguish what is possible from what is typical. So let me show an example that Melanie in her talk also used. So this is a paper. I think this is a misuse of the word counterfactual. They call this the default condition, the counterfactual condition. So they test various language models on the usual kind of task and then on an alternate version of the task. And now notice, right, in this experiment, as is typical, there are no human baselines, okay? So this is from Melanie's talk. And I think this is a quote from the paper. So a counterpoint is that much more often than not, so do people, right? So if we look at some of this, drawing, okay? We're all better at drawing a thing in its normal orientation than upside down, okay? We're also all better at recognizing things in their normal orientations than upside down, okay? Chord fingering, note and melody, right? Well, it's nice if someone can transpose these keys on the fly, right? But if they can't, if they can just do the normal thing, right? Well, we don't say, oh, I guess, you couldn't do this key transposition. I guess you don't really understand anything, right? At the same time, we want to distinguish what is possible from what is typical, right? All of these things, playing counterfactual chess with an alternate rule, like it is possible for people, but it's difficult. Like it always comes with a cost, but sometimes some of us can overcome it. And I think this distinction is important because often we are confused in the discourse. Some people care about this being kind of a model of a cognitive model, using it as a cognitive model. Other people care about these as industry production systems, right, that we want to use. So there's a paper with a very direct title, GPT-4 Can't Reason, okay? And the author uses mostly mathematical kind of case studies, simple proofs, detecting various contradictions to show that, like, okay, it's very hit or miss, right? Sometimes it gets things right, other things it gets things wrong. It sometimes gets the hard things right and the easy things wrong. It's not a sound reason. And very astutely, he addresses the possible critique that someone like me might make, which is, well, but people are like that too, right? And basically says, I don't care, right? He says, it's a very punchy piece of writing. If I find that the car I'm thinking of buying has a flat tire, it won't carry much weight for the dealer to protest that I'm cherry picking the data and that I should take into account how beautifully inflated the other 3 tires are. Okay, that's a 75% success rate after all. Just as we don't want a bridge that is 90% likely to stand up, we need sorting algorithms that work on all inputs, not just most of them. Okay. So I agree with all of that, right? And I don't want a language model as a sorting algorithm, right? I want a simple, provable computer program as a sorting algorithm, right? But that simple provable computer program, right, is not going to be scalable to other things that we might want language models to do. So we want to have clarity about what it is that we want to use them for. But if one wants to compare it to human baselines, right, we need to recognize human reasoning is not sound. That's why we invented machines and formal algorithms, right? Because on our own, we can't do that, or at least almost all of us can't. Be wary of it's just deflationary, it's just, right, deflationary explanations, right? And several other talks have touched on this. The idea that it's just next token prediction confuses, I think Raffaele Millieri used this phrase, confuses the learning algorithm for the learned algorithm. And it mirrors the point made by Dave Chalmers in his talk, right, that you could say, well, evolution just optimizes for reproduction, therefore, that's, how can you have anything other than that, right? So there's a category error here, right? It's an empirical question. What can and can't be learned through next token prediction? What can and can't be learned through natural language? But it's an empirical question. This cover image was meant to evoke a cave connection to Plato's cave, right? And Glaucon, the conversant in the dialogue, right? So you've shown me a strange image, and they're strange prisoners, right? The ones that are observing the world as shadows. And Socrates, it says, like ourselves. And Socrates believes that we can get out of the cave through reasoning introspection. But in a certain respect, right? Like this is this is a deep observation, right? We too are in a cave, right? We get senses, we don't have access to the real world. And so this kind of cartoon, right, of the language models being in the cave, right, but us not, right? That's wrong, right? We too, right, are limited to our internal world, right? And we get access to the external world, right, very indirectly. Okay, we see, right, through light bouncing off things, and we interpret and construct some version of reality based on that. The models are doing it based on language, right? It's amazing how far language takes you. Should we expect it to take you all the way? No. Should we expect vision to take you all the way? No, right? But these are not, I would argue, qualitatively different things.
And to protect you from yourself. I think you want some discussion too.
Yeah, I do. This is the end. And I think the next talk also has a clip from Sabine Hassenfelder, and I just saw this last night, and I want to put it in just about like AI risk and AI being like us. Let me just play this. It's 20 seconds.
Which is not no sound.
Yeah, I think it's because my sound is off.
See, the thing that worries me about AI is that we expect them to be better than us, more honest, more reliable, more intelligent. But what if they'll be just as dishonest, unreliable, and dumb as we are, because we can't teach them any better? Well, I'll keep you well informed throughout the apocalypse, so don't forget to subscribe.
Okay. I think this resonates with, so this is a quote from Dana that Kyle Mahald in this commentary raised, and that I would very much, I very much agree with, right? That it's a mess, and we should embrace it and study it as it is. Okay. Thank you.
Okay. There's already a question from Steve Hansen. Go ahead, Steve.
Can you hear me?
Yep.
Stephen, is there a video or?
I'm trying to.
Okay, well, never mind. Gary, that was just a fantastic navigation through what I think is actually a sea of counterfactuals. So, you know, if this was
there. I think I might have destroyed him by mistake.
Oh, let me try this again.
Okay, that's it. You're on.
Gary, that was a fantastic navigation through
Yes.
what I think is an ocean of counterfactuals and a lot of this kind of business, actual counterfactuals, where if LLMs were just a database, if they were just this, if they were just, well, the problem is we just don't know what they are. And the way that you subtly go through this, providing the contrast to human behavior, is very, very important, I think, in terms of understanding what the hell is going on. So one thing that strikes me, I have a lot more to say, but I'm not going to take up every time. But one thing I'd like to ask you about is the developmental aspects of the LLM. Clearly, somewhere between, you know, 100 billion and 1 trillion tokens, or maybe it's only 10 billion. We really don't know where the thresholds are here because no one's actually studied that specifically. So the question is, would a developmental psychologist looking at it, would they begin to understand something about the kind of emergence in language aspects that would pop up, you know, somewhere between that X billion and trillion tokens for GPT-4? In other words, it seems like it would be good to understand the dynamics of the language acquisition.
Yeah, well, so I think it's useful to separate the dynamics of language acquisition in a kind of grammatical sense, right? Can it produce grammatical surface level sensible sentences, and world knowledge, learning of world knowledge. And I think everything points to the first being much easier and requiring much less data and less compute than the second. So you see competent performance, I think, fairly early on with, you know, I think arguably with at least in the neighborhood of human input, where the gap is, my bet is not on, in this case, on embodiment that humans have and the models don't, but actually on agency, right? And so it's, kids are not just spoken to, they're part of meaningful discourse. They change the conversation, right? The adults are playing an active role here, where the adults are inferring what the child wants and delivering language that's relevant to the child in the moment. And so they're getting much higher quality, the input is just way, way more relevant. Children faced in the with the task that the LLMs are just getting passive text, right, would not be able to learn language, right? So I think that comes first, and then it seems that so far there's been this scaling phenomenon, and I think it's a combination. It's not going to be one thing. So it's a combination of, yes, having more experience, more exemplars basically to draw on and match to, which humans also do, just, pattern matching. It's not regurgitation, it's just matching similar enough patterns and adapting them to current use. But also, and I think the evidence is there, that the models, through lowering prediction error, are learning something like, they're learning some causal relations, some world or situation models, because that model is the way that lets you lower the prediction error most effectively. We would not expect this to happen in all the same ways that it happens for people, but having these kinds of developmental studies of the networks is essential. So looking at the time course of training, that of course, I mean, that's the kind of thing that, sweet connections did back in the day with toy models. But the same,
I remember that.
yeah, the same procedures apply, right? Legioning the models in various ways, training them on different kinds of corpora to see what parts are the most important and what parts, in some ways, right, make it worse, right? Because it's just it's noise in a bad way.
Yeah. Well, that's great. And again, thanks for the great navigation through all this mess.
Thanks. Yeah. I'm just gonna plug in.
Yeah, did you get to your attendees page? Because we're gonna go to great questions. The comments page.
Yeah.
I have it if you don't have it.
Yeah. Well, yes, if you want to do one.
No, I want you to, I don't want to read it out.
Oh, all right.
But what are you
Looking for a power. I guess I don't need it. Okay.
So just scroll through that one.
Yeah, so Alberto's comment that machines, in order to be intelligent, from by Neumann, do not just need data, they need to grow up as children and play games. This made me think, could machine-to-machine interaction be a way to study the development of category learning? So, I mean, there is a tradition of doing this that Luke Steels, for example, did a while back in the Sony lab. Yes, and I think it's a productive research program. I think it's been hampered, right, by robotics, and robotics are hard. And again, I think one lesson I've taken from the last few years is that embodiment certainly matters for people, but it's not the only way there, right? Like, people who are born congenitally blind learn a whole lot about the visual world through language. Do they have the same knowledge as sighted people? No, but they also don't just have isolated facts. They have coherent theories. They have causal models of the visual world, of shape, right, of this. So there are multiple ways of learning. I think interaction is more important than embodiment, and agency in particular, right? So children can ask questions. That's important, right? Children can change their environment, right? And the thoughts they have, right, is, right? So a current language model is waiting for us to prompt it, right? Children are not like that, right? They're agents in their environment. And so embedding language models in virtual worlds where they have to make choices, and this is not an original idea by any means, right, I think is hugely important. And we are running out of language data to train a model. I think it's silly to think that more and more language data will keep leading to breakthroughs. But actually learning in the way that animals learn, by being agents, like that, it's amazing that how far one can get without it. But yeah, I think it's pretty clear that one needs that kind of experience.
Before you go to the next one, you have a local one.
Yes. Yeah.
So I was going to point out the same objection that you add in the final clip, so that we want the machine to be the language model to be more efficient than an actual human.
Yeah.
But I wanted to shift to another problem at this point, which is if we ask language models to do tasks that we don't know how to do.
Yeah.
That's even a bigger problem, because we don't know we don't even know if they are as efficient as a human would be, or if something else entirely is going on there. So that's the real problem of the real question to us.
Yeah. Yeah, no, I think true novelty, and it's very hard to have a good distinction between, okay, this is, truly outside of training, right? But if one looks to the history of science, right, where really paradigm shifting insights, right, into the world, right, these are extremely hard and rare, right? And what's hard is precisely the innovation, right? Within a fairly short span of time, we figure out ways of conveying that knowledge, disseminating that knowledge in a way that's accessible to a much larger public, right? But often the insights, are very, like, everything kind of has to go right for that to happen, right? And I think we have to recognize human intelligence, and this connects to Mike Levin made, right? Human intelligence, right? It's a snapshot, right? And so to say that, like, what are people good at, right? Well, which people and when, right? So, we're good at touch typing. Like 100 years ago, people thought that touch typing was just impossible. No one can do it. It just, like, and there was a guy, I don't know if there was a guy who, like, went around county fairs. He taught himself to touch type, and he was like this curiosity, or people thought he had this supernatural ability, right? And now we take it for granted. And there's lots and lots of these kinds of things. So I am a bit skeptical at this stage about, machine science, right? Where, I don't see humans being out of the loop in the near future, right? What's interesting is, and what's more likely is, that some activities that we now think require great intelligence, synthesizing a literature and distilling kind of important things, I think in some cases are already being automated, right? But I haven't really seen the models produce anything that we might want to call genuinely new, but they could produce inputs to people that might increase the probability of new insights. But I don't think it's because, people have some special ingredient that allows them. Yeah.
List.
Yes, list.
Here, I'm sorry, here.
Yeah, it's this. Yeah. Okay.
You need me to guide you through these things.
So. Okay, Julia asks, the kind of consistency I think differentiates LLMs from people more is Gricean, related to building common ground during conversation. Example is asking whether any quantity raised to the power of 2 is equal to itself. ChatGPT vacillated yes, no, and provided plausible sounding justifications either way. That behavior feels to me not human-like. What is your interpretation? Yeah, I agree that it feels not human-like. There are nice demonstrations of how, this is a sort of the human consistency is sometimes an illusion, right? That we know kind of in the Gricean way that it's like weird to just change your opinion, right? From one moment to the next.
Like the Supreme Court.
The Supreme Court?
On abortion.
Yes. What about
It's weird, but what about, where's the common ground between the Supreme Court that said yes and then?
Well, I guess they, right. So the legal logic is interesting, right? Because it tries to have the air of, rigor, right? Which but anyway, maybe, and I go there, but it's so the kinds of experiments that, right, demonstrate the underlying inconsistency that we're often trying to mask. So I don't remember who the authors are, but experiments where you ask people to choose, you give them 2 options, you ask them to choose, subjective kind of thing, which one do you like more? Okay, and then later they're asked to explain their choice. But some of the time, and they were being asked multiple questions like this, And some of the time, the experimenter surreptitiously asks them to justify the wrong choice, okay, the one that they did not choose. And a lot of the time, people don't remember it because there are a bunch of these questions, and they go on to provide a reasonable justification for why they like the thing that 5 minutes ago they said they didn't like. So I think that's absolutely right, that in the real conversation, we know that's weird. We know people expect consistency, and we expect consistency of ourselves. But it's largely this kind of, I think, monitoring system that kind of often masks what underneath is quite a bit of inconsistency and context sensitivity. It seems that the LLMs from Anna Strasser, LLM studies are based on relatively small samples. One result was listed as 10 out of 10. Studies on humans usually involve more test subjects. How do you argue for such small sample sizes? So I wouldn't argue for such small sample sizes. And in my replication of it, I had a larger sample size. But I think, and yes, I mean, it's very easy to run the model multiple times. You can increase the temperature to make sure there's more variability, or you can just get at the underlying probabilities. That's often better than just rerunning it. But I think a more general point is that we shouldn't treat multiple runs of the model as different subjects. I mean, the model is not, it's neither a single entity nor is it a population. So sampling from a model is not quite the same as sampling different people. It's also not the same as sampling the same person multiple times. So we need to be somewhat careful here. Now, training multiple models on somewhat different data with slightly different architectures, treating those as subjects, more like early connectionism did, that's more accurate, but of course not, if you're talking about GPT-4, right, not practical. A sort of compromise that Ben Bergen and his colleagues did in that Turing test paper is to instantiate the same model, right, to prompt it, right, to have different personalities, to have different assumptions, right, and then you can run multiple tests on each of those, and that's not as good as actually retraining, but in the absence of that at least gets, the variability is. One can better make sense of, why these different prompts are leading to different answers if there's consistency there. Yeah. One more. Yeah, a quick one. Robert Liu, wait a minute. Pizza box is far from being a cube, and it's easier to balance things on a pizza box. Yes. So. So that's a good point, and one would want to test this systematically. I did try to constrain it at one point to cubes that have all equal sides, boxes that have all equal sides. It did not qualitatively change the patterns. It didn't seem to matter, but that's the kind of the kind of question, that's the kind of way we do want to think, right? That, okay, in some contexts, cubes and boxes are equivalent, but in other contexts, they're not, because, right, there are lots of boxes that aren't cubes. So if you're talking about a cube, you can interrogate the model to better understand what kind of cube, how big, in what orientation. Same thing for a box, right? And of course, same thing for people. We shouldn't assume that when we talk about a cube, what the person has in mind, right, is some mathematical abstraction. Maybe they do, but maybe not. So we want to we want to, and we can interrogate it further.
Okay, I'm sorry to be such a monster, Gary, but the panel session will be at 3:30, and you'll get much more time.
Yep.
Okay.
All right.
So
thank you all.
I want to thank you, and we're going to just about cut off.